Today I'm going to explain two different chemical equations in depth. My first formula will be nitrogen gas reacts with hydrogen gas to create ammonia. To start off, let's look at how ammonia is formed. Nitrogen has a charge of -3 and hydrogen has a charge of +1. We will use the crisscross method for this equation. Just simply take both elements and drop their charges. Once done, give the elements each other's charge and put it in front of their atomic symbols. The product would be NH3. The reactants of this chemical equation are nitrogen gas and hydrogen gas, and the product is ammonia. This type of chemical reaction is synthesis because there is only one product that the reactants are creating. We must balance this chemical equation by using the law of conservation of mass. This law states that matter can't be destroyed or created, only rearranged. For this equation, you can start on either hydrogen or nitrogen. Since there are two nitrogens on the left and one on the right, you must place a 2 in front of NH3. Now nitrogens are completed, but now you have to deal with hydrogens. There are 6 hydrogens on the right because 3 times 2 equals 6. Therefore, you must write a 3 in front of H2. Now the chemical equation is balanced. One major use of ammonia is as fertilizers, applied directly to fields in its liquid gas form. My second formula is potassium phosphate plus silver nitrate produces silver phosphate and potassium nitrate. How do we get this formula? Metallic elements will combine with nonmetals, therefore causing silver to combine with phosphate, and potassium will bond with nitrate. This chemical reaction is a double displacement because both reactant compounds are breaking apart and bonding with each other's elements. Like in the first equation, all that needs to be done is drop the charges and use the crisscross method. Balance this chemical formula by using a simple rule. Start with the polyatomic ions, then do elements bonded to something else, and finally choose the hydrogens and oxygens last. Let's start with the phosphate ions. On the reactant side of the formula, there is only one phosphate, and on the product side of the formula, there is only one phosphate. Therefore, they are done. Next, we should choose the nitrate ion, and notice that both sides only have one nitrate ion. Therefore, they are balanced. This causes us to change AgNO3 to 3AgNO3, and now the equation is balanced. Potassium phosphate is regularly used as a food additive. It helps stabilize, thicken, and regulate the acidity and moisture in foods and most drinks. Potassium phosphate can cause some side effects. These may include an increased risk of people with kidney problems to unintentionally consume too much phosphorus, and an increased risk for heart disease and a slight possibility of death. In this chemical reaction, one piece of evidence that a reaction occurred is that a precipitate was formed. There are very few similarities between equation number 1 and equation number 2, including that both equations have nitrogen, and they both have 2 reactants in it. The differences between these two reactions are that in equation 1, it is a synthesis reaction, it contains hydrogen, and it only has one product. But in equation 2, it contains oxygen, phosphate, 2 products, double displacement is the reaction type, it contains silver and potassium.